Today we discuss about the section formula, a condition in which suppose a telecom company want to set a tower between the two cities A and B at a point P that divide this distance in m1 into m2 ratio. This means this one m1 and this one is m2. If we plot this diagram on a coordinate axis, this is point A, this is a city, and B is another city. P is the point in which a company want to locate its tower. This is the point P. Today we discuss about the section formula. So let's suppose we draw a line from A to the parallel to the x-axis. This is and parallel to the x-axis from B. This is this angle and this angle will be 90 degree. So we can see here AP and this is the point, suppose M, and this is N. We can see here this angle equals to this angle and this will be 90 degree. This will be 90 degree and this will be 90 degree. If these two angles are equal, that means the third angle is always equal. That means triangle APM is similar to triangle PNB. If two triangles are similar, that means the ratio of the sides are always the constant. That means AP upon PB in these triangles APB and PBN. So AP upon PB, this equals to the AM upon PN, AM upon PN, and this will also equals to PM upon BN, PM upon BN. This is the coordinate axis where the point, suppose this is a point A and this is the x1 y1, sorry we cannot locate it, this is x2 y2. We know the location of a point on a plane, two pair of coordinate axes required. This is point B, this is x comma y and x2 comma y2, and this is A point, this is x1 comma y1, and this is a P point where we know the points. So this is unknown, this is x comma y, let's suppose. So this is the x1 distance, this will become x distance, and this will be x2 distance. Similarly, on the y-axis, this will y1 and this will this is y, okay, this is small y, and this is y2. This distance from the axis this is from the x-axis. Okay, so if we talk about the AM distance, this will x and this x1. That means that this distance become x minus x1. And if we talk about the PN distance, that means this distance, this is x2, this is x. That means this will become x2 minus x, this distance. So if we put the values of AM, PN, PB, okay, sorry, this is the y, then PM will become, this is a PM and this is y, this is y1. That means this distance y minus y1. And if similarly we talk about this distance, this is y2 minus y, y2 minus y. If we put these values on this formula, we can get AP upon PB equals to AM, that is x minus x1, PN, this is x2 minus x1, x2 minus x, and PM is y minus y1, and Bn Bn is y2 minus y. We know the distance ratio of AP and PB, this become m1 upon m2. Basically m1 and m2 is the ratio of our distances from A to P and P to B. So this will become AP upon PB, this will become m1 upon m2. This equals to x minus x1 upon x2 minus x equals to y minus y1 upon y2 minus y. So if we solve it, m1 once a time, this will equals to, and this will also equals to. That means if we equate x to m, we get x. That x will become x, we will get m1 x2 plus m2 x1 upon m1 plus m2. For y, if we solve it for y, that means this is a cross multiplication, m1 into y2 minus y. That means m1 upon m2, so we separate y minus y1 upon y2 minus y. If we cross multiply it, that will m1 y2 minus m1 y equals to m2 y minus m2 y1. Here we can m1 y, m2 y. m1 y moves